Hey guys! Welcome back to my channel. In this video you will learn about organochlorine insecticides and how they kill or harm insects. But before that, we make sure to subscribe to our channel and turn the notification on, so you don't miss any videos in the future. Insecticides are chemicals that are intended to kill or injure insects in order to boost agricultural yields. Insecticides function by interfering with an insect's neurological system, destroying their exoskeletons or restricting their growth. Insecticides are classified into two categories. Through a variety of processes, broad-spectrum insecticides affect the majority, if not all, of the insect species in the treated region. Because they don't harm beneficial insect species in the treated region, targeted insecticides are better for the environment. Other species are including bees, ladybugs and wasps. Whereas the goal is to eliminate hazardous insects. They will not be killed because this method only kills specific insects and not others. The use of a chemical to kill or injure insects is not a novel concept. Plants create some pesticides on their own, such as nicotine and pyrethrum. Insecticides can work in a variety of ways. Broad-spectrum insecticides are applied on stored products and begin functioning when an insect inhales them. Hydrogen cyanide, nicotine and methyl bromide, and naphthalene are examples of broad-spectrum insecticides. Insects with chewing parts devour insecticide-coated leaves, so this targets caterpillars, beetles and grasshoppers. Copper acatorita, lead arsenate, calcium arsenate, sodium fluoride and cryolide are insecticides that are sprayed on leaves. Arthropods that puncture plants to suck out the juices are the target of contact penetration. Nicotine is a pesticide that works in this manner. Pyrethrum, rotenone, organochlorines, organophosphates and carbamates. In the 1940s, dichlorodiphenyltrichloroethane was an organochlorine pesticide spray that was first used to replace harmful insecticides including lead and arsenic. DDT works by allowing the ion channel in nerve cells to open. This boosts the active transport of sodium and potassium ions across the cell membrane, resulting in the generation of spontaneous new impulses. The insect's muscles twitch as a result of the spontaneous firing of nerve impulses, which finally leads to convulsions and death. Lindane is another organochlorine insecticide that was previously employed. Lindane has a hexachlorocyclohexane structure. There are hexachlorocyclohexane isomers, but lindane is the only one with insecticidal capabilities. Lindane inhibits chloride ion transit in nerve cells, increasing the rate of respiration in insect cells, resulting in increased insect activity, twitches, conversions, and weariness. Lindane was used to treat food crops, seeds, cattle, and pets until 2006, when it was outlawed and limited. Chloridane is a chlorinated organochlorine pesticide. Chloridane is used to control termites and soil-borne insects. It is not affected by ultraviolet radiation from the sun, and its mode of action differs from that of DDT and lindane, because it inhabits nerve cells rather than accelerating their transit of chloride ions. However, it has the same negative effects as tremors, convulsions, as well as tiredness. The organochlorines are notorious because of their effects which were not known about at the time. Organochlorines are non-reactive and hydrophobic, which means they persist a long time and makes them appealing to customers but extremely harmful to the environment. Silent Spring, Rachel Carson's 1962 book. He represented the relationship between the advent of DDT as a substantial insecticide spray and developing environmental issues such as the incidence of malignancies and the decline of bird populations. When DDT and related organochlorine compounds are used on insects, any animal that consumes those insects becomes polluted with this minuscule quantity of insecticide at the top of the food chain, according to Carson. Falcons are examples of birds of prey. Hawks and eagles that consumes large quantities of small animals were experiencing the hydrophobic pesticide gathered in the fatty tissues of the birds. The shells of their eggs got thinner and hence were less likely to result in viable offspring, so population numbers declined as a result of bioaccumulation. As a result, organochlorine insecticides have been regulated and even banned in some circumstances. Nonetheless, due to their long persistence in soil and waterways, they continue to harm ecosystems. The use of insecticides remains controversial, and treated areas are closely monitored. The lesson for today. I hope you have learned something new today with us. Thank you for watching my video.